Hello everyone, it's October 13th. Alright, let's get right into it. Delete the middle node of a linked list. You're given a head, delete the middle node, and then return the head of the modified linked list. The middle node of a linked list of size n is n divided by 2 from the start using zero-base index, where x denote the floor, right? The largest integer less than or equal to x. So just remove the decimal point. So in this case, 6 divided by 2 is 3. 4 divided by 2 is 0, 1, 2, 3. 3 divided by 2. Wait, hold on. N is the number, right? So 1, 2, 3, 4, 5, 6, 7. 7 divided by 2 is 3.5. So we'll get 3. And 1, 2, 3, 4. 4 divided by 2, 2. So 0, 1, 2. Remove this. 1, 2. 2 divided by 2 is 1. So 0, 1. We'll remove this. Okay. So, 2 pointers. I need to land add stuff in front of it. Alright? So if we go 2 steps, I'm not sure if it's okay, let's say 1, 2, 3. Go 3 step. 1, 2, 3. It comes here. No, I wanted to come from before, so we start from the dummy node. 1. Okay, this started with dummy node and the other starts here. So 1, 2, 3. And we're on dummy node. 1, 2, 3. Okay, that works. How about this one? 1, right? And 2. Wait, hold on. That doesn't make any sense. 1, 2, 3, 4. I should go 4 times. 1, 2, 3, 4. They will land at the same place. So, which means I have to let the other one go first. So the other one need to go start from here, and I start from here. Then I go 1, 2, 2 steps. 1 and 2, 2 steps. Here's the same. We go 1, and this one go 1, right? In this case, I go 1. Actually, I can't even go 1. Yeah, how do you handle this situation? Yeah, this is like my starting position. This is the starting position, and then I cannot go. So this one will be here. Yeah, so we need to let the fast node to move first. Okay, let's try this. No test case this time. Oh, we're gonna have a. What if it's only 1? If it's 1, 1 divided by 2 is. Maybe I should have a dummy node and start from the dummy node. That's the same thing. From dummy node, we'll go 2 first, right? So we start from here. 1, 2, 3. And the other one, 1, 2, 3. Yeah, we should always go a dummy. Because with a dummy, then if it was only 1 node, then the first one moves 0, right? You have 0 to move. And this one will be move 1. So I move 1. Yeah, dummy is needed. List node next equals head. Okay, and then slow equal to dummy, right? We can start from dummy, and then fast, right? So you know, go 2 times. Say while fast, fast and fast on next. Fast equals fast on next, right? So we move 2 times. We'll move 1 step, and then you know how many? No, I just move. I should say if, right? We just move 1 time is if fast and fast dot next. No, fast, they're both at dummy. Okay, so fast, slow, they start with dummy. I say fast, yes, so fast on next, yes, then fast equals fast on next, right? So that's the starting position. Then we say while fast and fast dot next. Fast equals fast dot next. Slow equals slow dot next. Then we just keep going until end. Then slow shall be arriving at this position. And then it would just be slow dot next, right? Slow dot next shall equal to slow dot next. Slow dot next shall equal to slow dot next. And then, yeah, we don't care. I just want you to, I'll just let it dangle. It's fine. I'm gonna return dummy dot next. Okay, let's try this. See how this one goes. I don't think this will be the type of question people ask in interviews. Dang it. It's not right. Oops. First one is correct. Second one is wrong. The third one is wrong again. How? Alright, let's see. So they're both at dummy, and I say if fast, yes, and fast dot next, yes, fast equals fast dot next. So fast will be here, right? So this is our starting position, fast, and I say fast and fast dot next. Fast equals fast dot next. So fast is coming here, and then slow dot next, slow coming to here. And then while fast, oh, I need to keep going. So it should be an or, right? No, I think it should be a while fast. As long as fast is good, then we say if, now we know fast could equal to fast dot next, right? And then we say if fast dot next, no, if fast, so because fast would move, now we say if fast, then fast equals fast dot next, right? We move 2 times, but like that. And then we'll do the same thing here. This guarantees that we will always move the last step. That's just because we didn't move the last step. Try it again. Okay, this time's right. And the edge case, even odd, yeah. If this edge case passes, then we're good. Yes. All right, try this. Oh, it's a new problem. What? So slow. The heck? 4,000. How many test cases did they put in here? This is optimal. This is ON. How fast can you make it? Well, we do have a lot of ifs. Interesting. I don't know. You know what? Yeah, we have a lot of ifs. Maybe what we can do, well, fast definitely is good. So we can just say fast equals head, right? So slow is dummy. And now we say, oh yeah, we can always make fast equals head on next. This one's unnecessary. And then we say while fast, and fast equals fast on next. And then we do inline fast equals fast on next if fast, else none. So we do this. Let's see, maybe this one will be faster. Because the other one is just way too slow. Okay. Try it. We eliminate some of... it doesn't matter. Does not matter. I don't know, we have any better solution than this? This is ON. How much faster can it be? I don't know. 2095. Use slow and fast node to find the node right before the one to be deleted. A little tricky to identify where the fast node shall start. But overall, it's the same slow, fast node idea to locate the center. But it's extremely slow. Let's see, we have a solution. 2 pass. Yeah. Fast and slow. Yeah. Yeah, why? But I cannot do it this way. Why? I tried it, but it didn't work. I usually, hold on, let me try it again. Because I start from a dummy. That's probably why. I start from a dummy and I go with that. Let's see, I start from a dummy, right? So fast start from header, head on next, start from here. Then we say boom, boom, one step. So slow goes here. And then, yeah, and then I drop out. So if we start here and fast start here, It's the same thing. How? How does this one work? How do you solve 1, 2, 3, 4? Slow is here. Fast is head, down next, down next. So fast is here. While fast and a fast down next. While fast and a fast down next. Fast equals hey, it does work, huh? It does work. And I have a dummy. And I start from here. While fast and fast down next. And fast equals, and then boom, boom, right? That's the first move. And then while fast, then I don't move. Huh. So they have to start from here. With a dummy node, it kind of, I think it mess up. Also, it will stand here. It won't be here. Yeah. It's easier, right? It's easier. Yeah, maybe it is. Yeah, this situation also works. It's just there's only one, it doesn't work. Interesting. So not all questions shall use dummy node. That's basically what. So this is from the official solution without using a dummy node. Turns out that the solution is much cleaner if we ditch the dummy node. And so we shouldn't use a dummy node all the time, right? So yeah, if not head dot next, right, which is return none, which is 1. Otherwise, slow is head, faster is head on next on next. Yes. And then we say while fast and then fast on next, and return. Oh yeah, you will never delete head in this case. Well, now we don't have an if clause. I don't know. LeetCode is very slow on ifs. Yeah. Maybe it's much faster. Okay, it's not fast. It is. Oof. Damn. Yeah, LeetCode does not like. LeetCode does not like ifs. I just have one if. Just one more statement. Right? Basically one more statement. Yeah. Anyway. Okay, so that's that. I have some time. Let's try this. Let's see what this one is about. Number of ways of cutting a pizza. Given a rectangular pizza represented as rows and columns containing the following character. A is an apple, and dot is an empty cell, and then given an integer k, you have to cut pizza into k pieces using k minus 1 cuts. For each cut, you choose the direction, vertical or horizontal. When you choose a cut position at the cell boundary and cut the pizza into 2 pieces. If you cut the pizza vertically, give the left part of the pizza to a person. If you cut the horizontally, give the upper part to a person. Give the last pizza to the last person. Return a number of ways of cutting the pizza such that each piece contains at least 1 apple. Say, hold on. You have apples on pizzas? What the heck? Who eats pizza like that? Return modulo. Okay, so with this, a dot dot, a, and a dot dot dot. 3 cuts. The total number of ways of cutting the pizza. Holy crap. So we can cut one, we can cut this. That's 1 way. That's 2 ways. And that's 3 ways. Obviously we cannot cut here because then we have no pizza. It's this one will given, right? So we cut this and then we can do 2 cuts here. That's correct. We can cut here, then we can do another cut. Right? We need to cut the pizza into k pieces. Yeah, using k minus 1 cut. So I don't have 2 cuts, right? 2 cuts. Why can I do? Oh, you cannot cut here. If you cut here, then you have 1 left. So no matter how you cut, it is not going to work. Okay, second example. 50 rows, 10. Second example is a dot dot, a dot, and dot dot dot. Wait, is that the same? No, that's not the same. So the same thing, we're going to do 2 cuts, right? So obviously we cannot cut here, so we can only cut here. Vertically, we'll cut vertical first. So vertical is here, right? Then the left is given away, so we are remaining as this. Then we cannot vertical again. Horizontal, we cannot horizontal. So this is actually no, this is no good. So we have to cut horizontally. Horizontal cut. So now we have this. And horizontal cut is no good, so we have to do vertical cut. So that's 1. And that's the only one. That's only 1. Whoo-wee. I mean, what at 50? How big is 50? It's alright. But maybe it's, I don't know. Yeah, I think it's fine, right? It's fine. We can use 50. It's a bit bigger value, yes, but it's okay. Yeah, I'm thinking about using that to represent the states. The state of the board. State of the board. It could be like each row is going to be a value. Oh, but then you have to. Oof. Nope. Because it's only vertical and horizontal cut. So the state can be the top left corner. That coordinate determines, right? So we just use top left corner, okay? So we have the state. And for each state, we can compute the total number of cuts that's available, right? Then, once we get that, so basically at the beginning we do a cut. And after we do a cut, we find the total number of ways, which just, k minus 1, right? Total number of cuts. Total number of cuts. So total number of cuts is k minus 1, right? So yeah, so basically we want to find, given this, how many different ways we can cut it. And then like k equals 1, I can do 1 cut. So we can just cut it. Do it vertically, right? And then we take this. So we take this, define. Yeah, so for this, if we want to do vertical, we do vertical, we calculate this, right? And then this will give me 0. So this is 0. For this is 0. And then it will be all 0. So this will be 0. Then we'll do horizontal cut. Oh, let's try. It doesn't actually seem that hard unless I missed something. Yeah, so we'll try this. If it doesn't work, it just doesn't work. Okay, so in my mind, I would do it this way. All right. So what we're gonna do is we're gonna have a DP, and we will memorize it. So from functools, import RU cache, and I'll cache it. Then RU cache max size equals none. Okay, and then DP. What do we need? We need an I. We need a J. All right, and we need a remaining cuts. That's an integer. And this will return int is how many that we have. So blah blah blah, doesn't matter. So when we do, we're gonna return dp. Holy crap. The value could be huge, so maybe we need to mod along the way. Okay, let's go mod 10 to the 9 plus 7. Okay. So when I return dp 0, 0 with k minus 1 number of cuts, right? Okay, so if not remaining cuts, right? We don't have any remaining, then return 0, right? If we have remaining cuts, then we need to decide where to cut. And let's say we do vertical cuts first, okay? So for vertical cuts, we so we given this, right? So we just need to know on a column if there is at least one A. How do we accomplish that? How do we get that value fast? I don't know. There gotta be a way to do it fast. How about, because we can do ON to get it, which is fine. But what I do believe is we can do a 2D prefix sum, right? If we do 2D prefix sum, then we can calculate the sum of any range. We just need a sum of this range, right? Because the recursion can go long. So yeah, well, let's do 2D prefix sum. Holy crap, how do we do 2D prefix sum? I don't remember. So we will copy this thing. Let's do 1, 0, 0, 1, 1, 1, and 0, 0, 0. If I remember correctly, what we do is the first row will do regular prefix sum, and the second row I will add to the top, right? So this value add to the top, and this value will add this and then add to the top. Yeah, because each one is the whole thing. So this is the whole of this. So we'll add to the top. So, ooh, wait a second. Wait a second. Do I just add to the left? Hold a second. Hold a second. If this is the total, and then for here, for this one, this is the entire thing, right? Damn, how do we do this? I forgot. Or 1, 2, and 3. 0, 0, 0. So we do like that, and then we add vertically. So maybe 2, 3, 4. 2, 3, and 4. Yeah, so this one will be all of this and then plus, yes, that's the one. Then if we want to know how many is in this range, how many is in this range, right? So what we do is, holy crap, we do 3, right? So all this minus, damn, minus this, minus 1, minus 2 plus 1, which come to 1. So this one's 1. And oh, hey, we should put a function of this. Okay, let's put a function for this. Well, we can create it here, which is fine. We can say a board. Okay. Okay, go to this, and for row, okay, for row in pizza, right? Temp equals this, and then oh no, temp board dot append this. Okay, we append this, and then what? So board append this, and then for a item in row, right? What do we say? Nope, I think it'll be easier to do it this way. Append for it in row, and we just do int it equals a. Okay, then dot append. We can do better. We can do better. From it tools, import, accumulate. We can directly accumulate. Here we say list accumulate this. Right? So accumulate, so this is this. And we say if land board is larger than 1, all right, then we say for j in range, we'll probably get m and n. Mn is a rectangular, so yeah, land pizza 0. We always have pizza 0, right? We always have pizza 0. Okay, right. So for j should be range n. Say board minus 1, so new things we just do. J plus equal to board minus 2j, right? So we'll do this. Once we're done, we have the board. And board basically is our yeah, we can actually try. Yeah, this is a tough one, so it warrants that we have to go step by step. Every step I will check if it's right. Oh, this is actually a fun one. It's already 11 o'clock, so even if it's really fun, you'll have to cut it if it gets too late. Okay, so we don't have to do all of them. We only need to try. Yeah, this is like a kind of a POC type of stuff. Ways. All right, what do you want? I want for row in board. I want to print this row. 1, 1, 1, 2, 3, 4, 2, 3, 4. Exactly, yeah, this is what we want. All right, then we want a function called def query. Right, I want to query the sum given top left and bottom right. Okay, so top left I, right, top left j, bottom right I, bottom right j, and board. Pass the board. Board is just list of list, and this one will return an integer. All we need is, yeah, this is fine. So board is the prefix. I actually say 2D prefix. Now let's just call it 2D. Yeah, I want to make it more explicit. Prefix 2D. Pre-2D. Yeah, prefix 2D. Okay. All right. So what do we want? We want this one minus this. So we say, holy crap. So base is prefix 2D, bottom right I, and then bottom right j. Okay. Left remove shall equal to prefix 2D. It's gonna be bottom right I, and the I, right, the row is the same as bottom right, but a column is the top left column minus 1. If top left j minus 1 is larger or equal to 0, else, we can multiply. Let's multiply int of this, right? If it's equal to 0, not if it's smaller than 0, which means it's 0 itself, then we don't remove anything. Top remove, right, equals prefix 2D. Also, the top remove is going to be here, right? So we want this, so the bottom will be here, top will be here. So it is going to be, let's see, this one, right? And then we need to remove this, So the I is going to be top left I minus 1, right? Top left I minus 1 and bottom right j. Multiply by int top left I minus 1 is larger or equal to 0. Okay, and then diagonal add equal to prefix. That's basically just top left I minus 1 and top left j minus 1, right? Of course, we're going to multiply both. Right, we'll multiply this and multiply this. And then we'll return base minus left remove minus top remove plus diagonal add. So that's the query, okay? So now with query, I think we are ready. Okay, so I'm gonna do vertical cuts, okay? So we're gonna do one cut and basically see if it's 0, then yeah, there's nothing we can do. And if it's 1, then we can keep cutting it because it's fine, right? So, oh no, if it's 0, we have to keep cutting. Yeah, we have to keep cutting. It's fine. It's only O1 to get it. It's okay. So for vertical cuts, so res equal to 0, right? And then we're going to do vertical cuts for j in range. Oh, we have a j already. So q in range. So basically, I want this to be the one that I cut. So I cut here, cut here, cut. I can cut, not cut. The q is the index of the column that's going to be given away. That's a better. So q is the vertical, is a column, right? It's a column index that can say j to q is our j to q plus 1 are the columns to be given away. Okay, so for q in range from j, right? Because I want to cut from j all the way to, we cannot cut the last one, so n minus 1, because we cannot do, q cannot be n minus 1 because there's nothing left, right? Then we say, what do we say? If we query it, right? We query it, and it's always to the bottom. So we do this, remove this, do this, remove always to the bottom. So we query this thing, right? We query this thing, and if it's larger than 0, then we do that, and then we add it, right? And if it's equal to 0, then we just keep going. Okay, so we say if self.query, right? I want to query top left is going to be I and j, right? Top left is going to be I and j. Q is here. Top left is I and j. Bottom right, so Q is here. Bottom right, row is always going to be n minus 1. Column is going to be q, right? And prefix to d, right? So if this is larger than 0, then res plus equal to whatever the remaining we can do, which is dp. So basically we cut to q. So the next one is going to be q plus 1, right? I doesn't change. We stay on the same I, q plus 1, and remaining cuts minus 1. So that's that. If it's equal to 0, then we just keep going, try it again until we finish, right? So that's vertical cuts. Now horizontal cuts. Then when we do horizontal cuts, we're going to say p, right? And then we say I to p plus 1 are the rows to be given away. Okay? Then we'll say for p in range I to m minus 1. Yeah, we cannot go to the last one, so do this. So if self.query, now we do vertical, right? So this is I, and then this will be q, no, p, and all the way towards the right. So the top left is still I and j. The bottom right is going to be p, right? And n minus 1. N minus 1 is the bottom right. And then prefix to d, if it's larger than 0, then we say res plus equal to dp. P plus 1, right? And j, remaining cuts minus 1. And blah blah, we return res. Okay, you wanna try this? What the heck? I got 0. I got 0. That is not happy. I am not happy. What went wrong? Because I never have 1. That's the thing. I never have 1. So if this is 0, right, we need to have 1. 1 will be, because when you cut, right? Oh, if remaining cuts equal to 0, hold on. That means in the current case, we are in ij and the remaining cuts is 0. So we shall return, it's not 0. We shall return int something, right? Which is self.query something is larger than 0. What is this something? So we have ij is still n minus 1 and n minus 1. And we have missing 1 required. Prefix, of course. I forgot to put prefix. You know what? This is stupid. I don't want to put prefix here. Let's get all the prefix. Put a self dot in front of it. Then we don't have to worry about this. We just need to put in 4 coordinates. Yep. This one's quite right. Let's try the other 2. They're quite right. So now what we need to do is just mod. Okay, we can mod at the end, or we can mod in each step, which I think will be easier if we mod at each step. Let's say res plus this mod, right? And this will be same res plus this mod. Okay, let's give this a shot. Okay, so if it's wrong, then it's just wrong. I'm not doing it again today. It's 11:25. It is not wrong, and we got it right. Although the time is pretty slow. Maybe we can. What if we don't mod? Right? That's another thing. If we don't mod here, just now play around with this thing. We know it works. So plus equal to, plus equal to, if we don't mod here, right? And we do the mod at the end. I'm not sure. I think it's going to be faster. Let's try, see if it's going to be faster. Mod at the end. Oh, yes. Oh, yes. Let's mod at the end. I mean, the reason probably is just, for Python, they are pretty good. Python's pretty good at handling big number arithmetic. And I'm pretty sure this is the official solution. So, use 2D prefix sum to describe the pizza such that we can obtain the number of apples in any given range in O1. Then we use dp, right? We use dp to obtain the total number of cuts given the top left coordinate and the remaining number of cuts. And that's it. So the runtime. Well, what we have is OMN to produce this, and plus we have this. There's ij and the remaining cuts. Damn! So it's m and k. Okay. Yeah, this one's not too bad. Prefix summing matrix, exactly. OMN, n plus. I don't know. Why? Ooh, that might not be OMN. OM. No, yeah, it is OMN. Oh, I forgot about this. Oh, yeah, my bad. Yeah, it should be this, and then n plus n. That's true. Yeah, that's a pretty standard solution. All right, I'm pretty happy. Right, we solved this one. It's a tough one, supposedly, but I wonder the passing rate. I think this one probably have a pretty high passing rate. It's really not that hard, right? This one is not that hard. You kind of get into the feeling immediately. I mean, like DP is very obvious, right? DP is very obvious. It's a very well defined subproblem. And then you're just trying to figure out, okay, can I get a count as fast as I can? And the answer is yes, you can get as fast as you can because you can use a 2D prefix sum. And then the problem is solved, basically. Yep, that's it. I will see you guys tomorrow. Adios.